All right, there's a few types of expressions that we refer to as special expressions or special factors, where you can take a look at them, and there's a few specialized ways of factoring them. So we want to look at trinomial squares, difference of squares, and difference or sum of cubes. So trinomial squares, really, for me, a trinomial square, you're doing the exact same thing as we just did in the last section or the section before that, where I am looking for two numbers that multiply to 25 and add to 10. These ones are special because the two factors turn out to be the same thing. But when you're doing them, like x squared and 25, I'm looking for two numbers to multiply to 25, 5 times 5, add to 10, 5 and 5. So I'd have x and x here. I'd have plus 5 and plus 5. Notice that both factors are identical, and so what I can, rather than writing it just as x plus 5 times x plus 5, I can write it as x plus 5 squared. So that's an example of one where um, you have something called a trinomial square. But really factoring trinomial squares is no different than factoring the ones before that aren't. It's just recognizing that if there are two identical factors, you can write it as a square. So when you go down to these ones here, like this one, I guess you've got x plus 4 and x plus 4, which is x plus 4 squared. Two numbers that multiply to 16, add to 8, 4 and 4. Here, this is an interesting one, x squared plus 4x plus 16. I don't think it should be a trinomial square because um, 16 is 4 times 4, and 4 plus 4 is 8, not 4. This number probably should be something like 4. So two numbers that multiply to 4, 2 times 2, and add to 4 would be 4. So that would be a trinomial squared. What I had there originally would not have been. Notice that negative sign, same thing. If you have a negative sign, two numbers that multiply to 9 and add to negative 6, they're both negative 3, so this would be x minus 3 squared. So nothing too exciting in trinomial squares. Same as what factoring that we've done before. There's some more practice examples. Notice these ones a little bit bigger numbers, but if I recognize and say, well, 9p is the same as 3p times 3p, so if I do that and just sort of do my guess and check kind of thing, so that'd be 3p and 3p, and 25 is the same thing as 5 times 5. They're minus, and so I'm going to put two minuses here. And if I multiply 3 by 3p, that's 9p squared. This would be minus 15 minus another 15 is minus 30. Minus 5 times minus 5 is plus 25. Notice I'm just guessing and checking here. Lo and behold, it turns out that it is the same factor, so I could write it like that. Okay, so nothing too exciting with trinomial squares. Factoring other things called difference of squares, another real nice thing to be able to identify. You can identify these ones because usually there's just two terms in there. Sometimes they massage them so there's a little bit more stuff in there, but typically you've got two entities, both of which are squares. If you come to this case here, then when you factor that, what you do is put a y in the first slot, y in the second slot. 36 is a square, a 6 times 6, so I'll put a 6 here and I'll put a 6 there. And then the trick with difference of squares is that you make one positive and you make one negative. And when you do that, when you have opposite terms, what that does is it cancels the middle term out, leaving you with just two terms. Let's check this one. Y times y is y squared. Y times minus 6y. 6 times y is a plus 6y. See what's going to happen there? 6 times minus 6 is a minus 36. So these middle terms cancel, leaving me with y squared minus 36. And that's sort of the trick that you see with difference of squares. Here's another one. You start recognizing the numbers like 49, 7 and 7, 25, 5 and 5. So I can rewrite this one as 7, Oh, now this is x to the fourth, so I've got to separate it to squared here. And this will be 7x squared. So when I multiply them together, I get 49x to the fourth. What do you think you're going to have in the last two? Yeah, probably going to be a 5y to the fifth and a 5y to the fifth. When you multiply those together, you get 25y to the 10th. One's positive, one's minus. When you multiply them out, you'll come out to that. So that's difference of squares. Again, if you want, you can pause and try some of those questions in your textbook, see how you do. The last one is one that you really just use a formula for. Um, I've never been able to memorize the formula. I always have to look it up somewhere. Some people can memorize them, but I haven't. But if I have a difference or a sum of cubes, so here's x cubed. 27 is the same thing as 3 cubed. So if I have a difference of cubes or a sum of cubes like this, 64 is 4 cubed. And you start recognizing those numbers like I said. If I have that, then what I can do is I can just use the formula to help me determine what the factors are. So here I have x cubed minus 27. It's a difference of cubes, so I'm going to be using this formula right here. Okay, so I'm going to put bracket there and a big bracket over here. So whatever's in the first slot goes there. So this is going to be a x minus 27, like I said, was 3 cubed. So this would be a 3 here. And then a is x, so that's x squared minus a times 3. X times 3 would just be 3x plus b squared. So 3 squared would be 9. So there would be my factorization of this difference of cubes. Notice that I'm just plugging in numbers from up here. It's a good idea to make sure that you're rewriting this so that you know what A is. This would be A, and 3 would be B. And then you just plug those in everywhere you see them in the formula. Similarly with the sum of cubes, this would be the same as 4 cubed plus y cubed. So A is 4 and B is y. So when I'm plugging these into the sum of cubes formula, this one up here, a plus b, so it'd be 4 plus y. And then a is 4, so 4 squared, that's 16, minus 4 times y, which is 4y, plus b squared. b's y, so y squared. Done. So all I'm doing is using a formula and being able to recognize, I guess that's what I'm recognizing, is that it's a cube and it's a sum of cubes or a difference of cubes. So that gives you a little bit more exposure to other kinds of factoring that you might look at. Perfect squares, yeah, just do those like the regular ones and recognize that the two factors are the same. Difference of squares and difference or sum of cubes, two ones that are good to be able to recognize and then use the tools provided here to factor them. All right, have at it. Try some more questions. Give us a holler if you have troubles.